about how we do environmental scanning for aquatic invasive species and hopefully keep a little bit ahead of these curves. So without further ado, thank you, Heidi.
So good afternoon. I'm Heidi. I'm with the U.S. Fish and Wildlife Service, and I'm going to talk a bit about our horizon scanning for aquatic invasive species. So we're going to start with a bit of context for this work. This is probably familiar to most of you, the invasion curve. It just reinforces that our most effective management for invasive species is prevention, followed by early detection and rapid response. So the more they get established, control costs go up, impacts go up, and the potential for effective control goes down. So we really want to focus on the beginning of the curve, the prevention and early detection. So knowing that prevention is the most cost-effective stage, how do we know where to focus our prevention efforts? Because we all know that our resources are limited. This is where horizon scanning can come in and help. Horizon scanning allows us to figure out what's potentially coming next. It's a process that's broad across the board, pretty much any industry can use. So we're looking at what invasive species that we need to worry about that we're actually not thinking about right now, that we're not aware of. And so recently, the Department of Interior has put forward this National Early Detection and Rapid Response Framework. So this is coordinating efforts across the entire department and all of our partner agencies. And at the beginning of this framework is horizon scanning and the watch list that come with them. So we have three kind of horizon scanning processes that we focus on. There's the global horizon scans, which is really focusing on species introductions into the United States. Asset-based horizon scanning, where we're looking at specific threats to things like national forests or hatcheries. And then what the service is focusing on is our region-based horizon scans, where we're looking at introduction and secondary spread within the US. And our objective for these regional scans is to identify species of fresh and brackish water fish, macroinvertebrates, or plants at risk of arriving in a target region of the United States and establishing populations there via unintentional movement. So far, we've completed or have 9 regional scans in progress. The kind of bluish purple color are the ones that we've done, they're completed. The green ones are what's in progress right now. And the orangish color is what we kind of expect to start doing in the next couple of years. But since this is New York AFS, we're going to focus on the scans that cover parts of New York. So we have 4 scans. The Great Lakes one has been completed. Northeast and Ohio River Basin scans are in progress, and we expect them to be wrapped up during this year. And then we're also going to start the Mid-Atlantic Rivers one later this spring. So how do we actually do a horizon scan? Our process is broken up into kind of 3 phases, and we've designed it to be adaptive. We want to focus on regional priorities and to be able to incorporate changes in horizon scanning science and best practice that's coming forward as we do this process. So in our first stage, the scope definition, the first thing we do is actually gather a regional advisory group. So these are managers and researchers and anyone interested in invasive species in that region, because we want our work to be regionally applicable for everyone to be able to use it. And to do that, we need to know regional priorities and try and reduce our bias as much as possible. And that regional advisory group helps us identify what introduction pathways are most important to them, really define the specific geographic boundaries that we're going to use. You might have seen on the map before, some had state boundaries, some had watershed boundaries, and really identifying our taxi groups of concern. And we're talking large taxi groups, so like families, orders, not specific species. And for the scans that are completed or in progress right now that are of concern for New York, there's been a handful of introduction pathways that are of concern, but there's been a couple common ones through the scans. Release of live bait, species dispersing naturally through hydrologic connections. So this is canals, flooding, stream captures, and also hitchhiking and fouling on commercial activities. This would include ballast. And then into our priority taxi groups. In the Great Lakes Basin, we focused on 2 orders of fish and a family of macroinvertebrates. And then in the Northeast and Ohio River Basin, it was a much larger group of families of fish, macroinvertebrates, and aquatic plants. But also, those 2 scans were really focused on that hydrologic connections pathway. So we looked at species with records of non-indigenous occurrences in the surrounding watersheds to our focal region. So now that that first stage is done, and we know the scope of what we're doing, we move on to the second stage, where we're really putting together our initial species list of what might be introduced. To do that, we take our identified introduction pathways, and we look for data that might help us quantify how much movement there is in that pathway and where the origin points for those pathways might be. Once we have origin points, and the origin points that might contribute the most to the pathway, we start with a really broad kind of coarse filter for could species in the donor region establish in our focal region if introduced. And to that, we do some climate matching. Once we have donor regions that might have species that could be established, we move on to looking at what species in our focal groups in those donor regions are present there, but not in our focal geography. So we're going to focus on the Northeast scan for a little bit to kind of walk through this process. So we started with pathway data for recreational activities. We looked at boat launches where their last launch location was outside our focal region. And we also looked at out-of-state fishing licenses. So where the person's home address was outside our focal region. And that kind of helped us identify those areas that contributed the most to this pathway. We then had those areas and we did some climate matching to figure out, again, could a species present in that area potentially establish in our focal region. And again, this is for the Northeast. And we're not saying that, you know, these areas have a perfect match, but that some area in the donor region could match some area in our focal region. So on this map, the orangish red color indicates donor states or provinces that had a suitable climate match to the Northeast, and the gray areas are ones that didn't. Anything not filled in was not on our top donor list. Now that we have those top donors with the climate matches, we go to building our initial species list. So we are looking for species that are in those focal taxa groups present in the donor areas that are not present in our focal region. And we're using publicly available occurrence data sets like the Global Biodiversity Information Facility, USGS NAS, and that gives us a pretty large list, which moves us into phase 3, which is where we do some risk screening and prioritization. These lists can be hundreds of thousands of species long. We don't have the capacity to do the risk screening for all of those. So we need to be able to prioritize that list to know which ones are most important for us to do risk screening on. Then to do that risk screening, we use the services approach of the ecological risk screening summary, which there is a poster on the library from Sarah Rubenstein that details that whole process. Okay, so how do we prioritize? How do we determine this? Again, we kind of went back to our advisory groups and we're like, what would be of most concern to you? What would make one species over another be of more concern? And we had a little bit of methodology change in the times that we did this. So for the Great Lakes and the Northeast, we gave our advisory group a list of criteria or characteristics of species that we thought might weigh one more heavily than the other being of interest. And they both prioritized that a species had a history of introductions and that in addition to be present in our focal pathways, that species was also present in a trade pathway. And then we got to doing the Ohio River Basin, which was in our most recent set of scans. We had been thinking of our methods, trying to figure out where are the areas where our bias might still be influencing this process, and realized that maybe we should ask the advisory group to give us the characteristics and criteria for prioritization and ask them to rank those instead of us determining what the characteristics might be. So doing that, we actually got some different answers. And for the Ohio River Basin, it was magnitude of known impacts. So the more broad of an impact is an ecosystem-wide impact versus just on a specific species would be more concern. And then difficulty to control an established population, where if we have known, well-documented control methods, maybe there's a biocontrol, that would be of a less concern than a species coming in where we have no idea how to control it. So after our risk screening and prioritization, we have our initial species list, hundreds, thousands of species. We're able to narrow it down to our watch list species. And those are our species that have a decent climate match for the species itself to the target region, and also what we call a high history of invasiveness. So that means there's documented introductions that resulted in established populations and documented negative impacts to either the ecosystem, the economy, or human health. And the watch lists for the Northeast and the Ohio River Basin aren't quite finalized yet, so those numbers might change a little bit. All of the completed reports for all of our scans are found on SurfCap, so you can just search for horizon scan as your search term and they'll pop up. But again, since we're focusing on New York, we can take those three lists and build a New York focused watch list. Currently it has about 38 species on it. That might change as the Ohio River Basin and Northeast list change, and as the Mid-Atlantic rivers scan progresses and develops. So currently, we've got some common species that we probably are all aware of: silver and bighead carp, rough, European perch. Those aren't really surprising. But there's also a few that we might not be really aware of yet: Eurasian minnow, stone morocco, signal crayfish, and wingleaf water primrose. A couple of these impacts: Eurasian minnow alters benthic macro invertebrate communities, and it also impacts native trout populations where it's been introduced. And then signal crayfish has massive impacts on native species populations, but also it carries diseases and introduces novel disease. And then I'm going to round up with one that's on this list that we might not think of for New York State. Completely surprising. It's red-bellied tilapia. It has significant impacts. It's a commercially important species. It's spread around the world, so we know it has a high history of invasiveness. So you might be thinking, it's a tilapia, it's New York, would it really establish? And given our climate matching, I can't say no. So I'll go through these maps a bit. The bottom one under the fish, that's our source point map for our climate matching. It's a bunch of gray and red dots, where the red dots are climate points within 100 kilometers of a known established population of the fish. And then our climate match maps, the shades of pink, lighter pink is lower climate match, darker pink is higher climate match. The top one is under current climate conditions, generally lower, but it's still above our threshold where we can't confidently say it would not establish. And then this kind of concern gets a little more if we take into effect climate change. And that's that bottom map. So this is scenario SSP5. It's kind of like really fossil fueled generation as we're going forward, and year 2085. So a bit more extreme, a bit out of the future, but there is increase in the climate match, especially in the Finger Lakes region. So even these species that, you know, we definitely might not think about if someone just came up to me and was like, how do you think about tilapia in New York? The horizon scanning and risk